In this video, we are going to solve some questions about limits. Let's find limit of fourth root of x as x approaches 0 from the right side. When x is bigger than 0 and close to 0, fourth root of x is also 0. Therefore, the first limit is 0. Limit of fourth root of x as x approaches 0 from the left side does not exist, because f of x equals fourth root of x is undefined when x is smaller than 0. Similarly, limit of square root of 1 minus x as x approaches 1 from the left side, square root of x minus 3 as x approaches 3 from the right side, and fourth root of 1 minus 2x as x approaches 1 over 2 from the left side is 0. Limit of square root of 1 minus x as x approaches 1 from the right side doesn't exist, because when x is greater than 1, square root of 1 minus x is undefined. Limit of square root of x minus 3 as x approaches 3 from the left side does not exist, with the same reasoning. When x approaches 6 from the right side and left side, absolute value of x minus 6 is 0. Therefore, limit of absolute value of x minus 6 as x approaches 0 is 0, since the right side and left side limit both exist and they are the same. Next example, limit of f of x as x approaches 1 from the left side. When x is a little bit less than 1, f of x is x, and limit of x as x approaches 1 is 1. Limit of f of x as x approaches 1 from the right side. When x is bigger than 1, f of x is 2x minus x2. Limit of 2x minus x2 as x approaches 1 is 2 minus 1, which is 1. Therefore, limit of f of x as x approaches 1 is 1. Limit of f of x as x approaches negative 1 from the left side, it must be less than negative 1. We have to use x plus 1 to the power of 2. This limit is 0. Limit of f of x as x approaches negative 1 from the right side is a little bit more than negative 1, negative 1. We use f of x equals x, as you see here. Since the right side and left side limit are not the same, limit of f of x as x approaches negative 1 does not exist. In these questions, we try to say when under radical is negative, the limit does not exist in first 4 examples. And when the right side limit and left side limit both exists and they are the same, the limit exists. When the right side limit and left side limit are not equal, the limit does not exist. Next question. Limit of square root of 3x plus 2 minus 2 root 2 over x2 minus 2 as x approaches 2. Let's try direct approach. If we plug in 2 into the function, we get the square root of 8, which is 2 root 2 minus 2 root 2 divided by x2 minus 2x. It's 0 over 0, this indeterminate form. So direct substitution failed. We try to simplify the function. We rationalize the numerator of the function by times and divide the numerator by its conjugate. The conjugate of square root of 3x plus 2 minus 2 root 2 is square root of 3x plus 2 plus 2 root 2. If we multiply the numerator, we use difference of squares, 3x plus 2 minus 8, which is 3x minus 6. We factor 3, the numerator would be 3x minus 2. The denominator can be written as x times x minus 2 times square root of 3x plus 2 plus 2 root 2 as x approaches 2. Since x is not 2, we reduce the fraction. By reducing the fraction, the limit would be 3 divided by x times square root of 3x plus 2 plus 2 root 2. When x approaches 2, the numerator approaches 3, and the denominator approaches 2 times 4 root 2, which is 8 root 2. Therefore, the given limit is 3 over 8 root 2. The key here is reducing the fraction by x minus 2. Whenever you get 0 over 0, you have to reduce the fraction by x minus the number that is approaching, in this case x minus 2. Next question, limit of x3 minus 5x2 minus 4x plus 2 divided by x2 minus 16. Our first attempt is direct substitution. We get 64 minus 80 minus 16 plus 20. That means numerator is a number and denominator approaches 0. Therefore, the limit does not exist. Next question. If we do direct plug-in and limit of cube root of x plus 8 minus 2 over x as x approaches 0, we get 0 over 0. We use substitution method. We assume cube root of x plus 8 is u. Therefore, the limit can be written as limit of u minus 2. If cube root of x plus 8 is u, x plus 8 would be u3. That means x is u3 minus 8. Since x approaches 0, u approaches cube root of 8, which is 2. This limit can be written as u minus 2 times u minus 2 times u2 plus 2u plus 4 as u approaches 2. Difference of cubes, we factor the denominator. Then the limit would be 1 over 4 plus 4 plus 4, 12. So in these questions, we had one question when the numerator is a number and the denominator is 0. The limit does not exist. One question, 0 over 0, we found it by rationalizing the numerator of the function. And the last one is, again, 0 over 0, we use substitution method. Thank you.